Alright then, hello guys. Today we're going to be doing another crypto hacks challenge, and the challenge we're going to be doing today is going to be called size and basis. So it says we say a set of vectors of v1, v2, vk, and to the v are linearly independent if the only solution to the equation so is for a equals 1, a equals 2, and a equals k equals 0. To visualize this, think of a vector directed out of a point. Given a set of linear independent vectors, the only way to return back to the original point is by moving along the original vector. No combinations of any other vectors will get you there. A basis is a set of linearly independent vectors such that any vector can be written as w a1 times v1 plus a2 times v2. The number of elements in the basis is also the dimension of the vector space. We define the size of a vector denoted as b using the inner product of the vector with itself. So the size of a vector is the inner product of itself. A basis is orthogonal for vector bases, and the inner product between two different vectors sizes between any two different vectors is 0. A basis orthogonal is orthogonal and if the size of the vector for equals 1 for all 1. That's a lot of stuff, but we'll be needing it. Time for the flag. Given the vector 4, 6, 2, 5, calculate its size. So I guess first we want to calculate the size of a vector. So you could probably look that up. Calculate the size of a vector. So calculating the size of a vector is nothing more than just the square root of the sum of the squares of its components. So if a vector is made out of x2 plus y2, so basically if it's a 2D vector, you just take it 3 to the power of 2 plus 4 to the power of 2, add them together and do the square root of it. In this case they have 3, in which they do it with 3 different numbers and then take the square root of it. So we'll do that, but with Python. So we'll just open up my Linux based or my terminal, and then from here on we should be able to get our answer that we need. So let's see right here. So it gives us 4625. So we'll wait for this to load up. So we'll do Python 3, and then we'll do power. I think it's, if I remember, I think you can do 4 to the 2. We can just test this theory out. 16. So it's just power 4 to the 2 plus power plus 6 to the 2 plus power 2 to the 2 plus power of 5 to the 2. And then I think you just do s square root. This might be a built-in function, I'm not sure, but we're about to find out. Yeah, there's no square root, so please look up square root in Python. SQRT, that's what I did, but is it importing a function? Import math. Okay, it's perfect squares. The math, okay, so it's only available in a math function. Yeah, so we gotta import math. So we'll just do import math. Then we'll just do math SQRT, and then we'll just wrap this around and just copy and paste this following right here. Now if we do this, we get 9. So 9 should be our flag, and if we check it right here, we get the flag was 9. So yeah, that was our final answer. So something pretty easy, nothing too difficult, nothing too hard. Hope you guys learned something new today. I know I did, and I'll see you guys in the next one. Peace.